Welcome to another Introscope video. Today we're going to be going over conditions. So the definition of a condition is basically a statement that the compiler checks before executing some other statements that are under that specific condition. A good example could be the famous to be or not to be, but this is just a fun example, but it's not generally used in Java, and if you put that statement, it wouldn't run. So you probably have not learned this yet, but an exclamation mark in Java means basically not. So to be or not to be. So whenever you have the exclamation mark preceding, let's say, not, and then a statement, that means it shouldn't be that statement. So before we get into if-else statements, I'd like just to give you guys a real-life good example of if-else statements. So let's say that the weather is really cold, as it is these days where I live. So I'm saying if the weather is cold, I will wear a jacket. Else, if the weather isn't cold, I will not wear a jacket. This is a really basic, simplified example of an if-else statement. But in Java, you'll be getting into more complex, but for simplification purposes, just think of this when you're starting. So what is an if-else statement? I mean, an if statement. So an if statement is basically a statement the compiler checks before executing code within the statement. And it's used with curly brackets before and so before these statements, and then to close these statements within the if, you want to use curly brackets. And this condition is obviously a Boolean statement, which we learned as one of the primitive data types. And if there's only if statements within, let's say, a set of code, then those if statements will be independent of other conditions. So let's say that if apples is greater than 10, I'll set the apples equal to 100. If the oranges is greater than 10, I'll set oranges equal to 100. That means that both of these can be satisfied, and they can both be true. So they're independent of each other. Else if and else statements. So else if statements. Else if statements are statements like this one, but sandwiched in between an if and then ending with an else. But we'll get to else's later. So if this is paired with an if and an else statement, then it depends on the if statement and possibly other else ifs. So let's say that if apples is greater than 10, apples will equal 100. Else if apples is less than 10, apples equals 50. Else if apples is less than 5, apples is... So you get the point. So these depend on each condition preceding it. If the condition is not true for any if or else ifs, then it will move on to the current else if to see if that's true. And if all of the else if statements are not satisfied, then it will go to the else statement at the end as the last resort. And if this is paired with an if statement and or else if statements, then it depends on the if and else if statements as well. Pretty straightforward. And yeah, I think I've covered everything for if and else statements. So conditions are Boolean expressions, and they're usually within the if and else ifs. Not usually, they're always. They cannot be used in else. So an else will not have the parentheses. An else will just end off else, because the compiler automatically knows if this is not true, then it's automatically going to execute the statements with the else. Logical operators. Two and signs means and in Java, and both of these conditions must be true for the whole statement to be true, or all like multiple conditions or all of the conditions must be true. We'll get into that later in De Morgan's law. Two parallel, basically parallel lines means or in Java. So this or that, A or B, and at least one of the conditions must be true to return true. So let's say I ask someone, do you have a cat or a dog? If they say I have a cat, then he answered my question. That's true. For and, do you have cats and dogs? If the person responds, I only have cats, then he did not satisfy the question, the statement that I asked him. Do you have cats and dogs? De Morgan's law is he was a great mathematician, and he basically set up these series of logical statements, these logical rules. And as you recall, the exclamation mark means not in Java. So this statement is basically saying if in the quantity of A or B. So if it's not the quantity of A or B, and that basically translates to if something is not A and not B. So whenever you see this, basically distribute like you would do in math, and then replace the or with an and, or vice versa, the and with the or. If you want more practice with De Morgan's law, we can give you, just feel free to check out our Introscope website, and we will go into De Morgan's law into more depth. And then short circuiting is basically, you don't need to really know it, but it's when the compiler checks if half the statement is true as a shortcut. So let's say you have a statement with like A, if something is A and B, then if A is false, then it'll just not focus on the B statement, because then you have automatically failed to validate the statement. Alright, and that is it for conditions. If you want more practice, feel free to check out our Introscope platform practice page. We will have a guide posted if you want more for your understanding of conditions. So that is it, and we'll see you next time.